Okay, here's a trip down memory lane for us. We are going to graph this line, y equals negative, negative 8x plus 3. Wow, that was a big circle. Anyway, so just to kind of remind ourselves, we find the y-intercept at 3, and then we use the slope of negative 8, which means you come down 8 and you go to the right 1, right? Because negative 8 over 1. Down right 8, right 1, and then you have your line. Now, you only need 2 points in order to graph a line, and I'm obviously doing a really horrible job, because that is a crooked line. It's always good to have more points and not be in a hurry. All right, just to remind you about how to graph lines, because now we're going to be graphing what are called piecewise functions. Okay, piecewise functions are pieces of lines on a graph. It means they're going to be broken up. They're not necessarily going to be connected together, okay? So let's remind ourselves, hold on a second, on a number line, when you were given this kind of stuff way back in the day, like middle school stuff, x is less than 0, you did an open circle and you drew an arrow to the left. And then when you got x is greater than or equal to 0, you did a closed circle, arrow to the right. That's going to be true in this case too, but now they're going to have different slopes. They're not just going to be on a number line. Not all of them are going to be horizontal. Some of them might be, and some of them will be, but not all of them. Okay, so let's see here. I suggest, because every line in the universe needs 2 points in order to graph, I suggest that we do that. Make a table. You're going to notice every single time I do this that I always pick the number that's given to me. Now you might say, Mr. Staley, it clearly says less than 0. It does not say equal to 0. It doesn't matter, because that's where your open circle is going to be. So you need to find that coordinate, otherwise you're never going to know where that open circle goes. Okay? So 0 is the first one, and then I have to pick something smaller than 0. So I chose negative 1. If I now take these values and plug them into here, 4 times 0 is 0, and 4 times negative 1 is negative 4. Okay? And I perhaps should write them on there with the other writing tool. Pause for station. All right, so if I go down to the next one, greater than or equal to 0, once again, always choose the number I give you, and then pick something that fits the category. In this case, 1 is greater than 0. Those will get plugged into the second one, so 0 plus 5 is 5, and 1 plus 5 is 6. Okay, now we can go to the graph. Let me clear all that out. Clear. All right, back to, well, that's not what I wanted, seriously. Okay. All right, now, I've got my points. So I'm looking for something that has something at 0, 0, okay, and it has to be a close, or the open dot has to be at 0, 0. Well, this one does not, so I can get rid of that. And then it has to go through the point negative 1, negative 4. And if I zoom in on some of these, we can take a look at it and see if, okay, so these go by 2, so negative 1, that's 2. Oh, well, that one's good right there. Negative 1, negative 4. So it's open circle, arrow left. Okay, so that's got the right slope. Now let's see about the other part. 0, 5, and it goes through 1, 6. So 0, 5, closed dot. Okay, that's good. And then 1, 6. Hey, that's the winner right there. So it goes through the correct points. So it is choice A. Okay, on the next question, question 3, you can see that I'm going to be using a closed dot arrow left and an open dot arrow right, according to the information that I've been given. Got to keep that in mind. I suggest you draw that on there every time you do a problem, just to make sure. Okay, so I'm starting with the number that I've been given, 1, and then I have to pick a number that's less than that, so I pick 0. For the other one, I have to start with the one I'm given, 1, and pick something greater than 1, which is 2. So if I plug these two numbers into the first one, that would be negative 1 and 0. And if I plug these two numbers into the second one, okay, 1 times 2 is 2, plus 2 is 4. 2 times 2 is 4, plus 2 is 6. Okay, so those are the points I'm looking for on a graph. So I have to have a solid dot on 1, negative 1. A solid dot on 1 and negative 1. These are not it. I can get rid of those choices. Man, I need a different color. We'll go red. So these both have the solid dot at 1, negative 1. We can zoom in on them a little bit so you can see them better. And then they have to go through, what was the other one? 0, 0, okay? Ooh, they both go through 0, 0. You can see it right there. They both go through that point. So that doesn't ruin either one of those. Oh, look at that. I see the double, that one right there. That's going to get rid of this choice right here because it needed to be an open circle, arrow right. And I bet if we looked at the coordinates, 1, 4, yeah, that's right, 1, 4. Each one of those tick marks is going by 2s. And then 2, 6. It'd be easier to see if they went by 1s. I don't know why they do that, but they did. Surprise, I'm in the other corner. All right, so solid dot arrow left, open dot arrow right. Okay, got that information first. Always use the number I gave you, and then this one says less than 0, so I picked negative 1. I will tell you when there's another time where I might show you, pick a different number other than just 1 unit away from it. Sorry for yawning. A little tired. All right, so starting with the 0 I gave you, and then pick a number bigger than 0, that's a 1. Okay, so take these numbers, plug them into the first equation. That would be 0 and negative 2. I think I'm going to use a slightly bigger pen. Yeah. Okay, and then plug these numbers in to the second equation, and that would give me 4, right? 2 times 0 plus 4. And 2 times 1 plus 4 would be 6. Okay, so now we need to find some possible graphs that have that situation. So we want a closed dot at 0, 0, closed dot, closed dot. Oop, you can get rid of these two choices, closed dot, 0, 0, has to be, and then they go through the point. Wait a second, did I do that right? Less than 0, negative 1, negative 2. Close. Hold on, for some reason I'm wigging out here. No wonder I was having a problem. Did you see my problem? Right there. Negative 1 times negative 2 isn't negative 2? Gee whiz. Yep, got to find your own mistakes. And that was a good way to find it, evidently. So I want negative 1, positive 2. Now, if you take a look at B, I think you're going to see that this one goes over 1 and up 2, which is what we want. This one is going over 1, only up 1, and that's kind of really not being drawn very well. So I don't think it's letter choice A. I think we're looking at B, and if we go through the process, 0, 4 should be an open circle. Now, they did each one of those blocks. Wait a doggone second. They're really being ugly now. I better back up and make sure my answer's right there. Okay? Because I've noticed that they went by 3s. Okay? So maybe the reason I looked at it was because open circle, this is not like on an even block. It's supposed to represent 4. Okay, and then 1 is supposed to be at 6. Well, this does look correct because that's ugly. I don't know why they would do that. I don't like that scale. So you're going to have to be careful on this stuff. I mean, this did remind me of the right one because it looked like it went over 1 and up 2. But I didn't realize that the 2 stopped shy of the actual tick mark on the graph. That is an ugly scale. So maybe if you want to if you want this to go better, maybe you should choose values that you see on the graph like 3, 6, 9, something like that, or negative 3. That might make it way easier for you. Okay, so I like that thought. Wish I would have had it a few minutes ago. Okay, so we talked about domain a while ago, and so that's what they want next is finding the domain. So this is the correct picture. We said what happens if you push all the points down on the x-axis. Well, what you're eventually going to have is everything, all the real numbers, all reals. And so the notation you better get used to is the interval notation, negative infinity to infinity. Notice I put parentheses on both ends because you cannot grab infinity no matter how hard you try. A bracket would mean that it actually equals that value, but that's not the case. Now, if they're going to ask me about range next. Range, as we recall, let me get rid of some of these lines in here. Range, as we recall, is where you, hold on. All right, so range is where we push everything onto the y-axis. So imagine pushing all these points onto the y-axis and forever and ever and ever, and we say how much of the y-axis would be covered. Well, it looks like it would start at 0 and it would go up from there. So that would be, hold on, you can see that the y values are greater than or equal to 0, starting at 0 and going up from there. So in interval notation, what that means is, got to show you something here. Hold on. So we will need a bracket here with a 0, and then it goes up to, well, that's where infinity's at, right? So we're talking 0, and it's going up to positive infinity. So that's what we mean when that's called interval notation. So we have inequality notation here, interval notation here. Let's take a look at what they want us to use. It says, if the solution is an interval or a union of intervals. We won't get into union of intervals right now. Type your answer. So that would be the negative infinity to infinity. And the, bracket. Why do I keep doing that? Bracket 0 to infinity. Okay, so you wouldn't be able to use the y is greater than or equal to 0. Okay, question 5 here. All right, zooming in here. Let's change to a different color. We'll use purple. So we got the solid dot arrow left, the open circle arrow right. We know that we're going to choose -1 and something smaller than -1, which would be -2. We're going to choose -1 and something bigger, which would be 0, okay? And then we're going to plug them in. So let's see, if we plug in these two into this one, and these two into this one, see, so -2 minus 1 makes -3. -4 minus 1 makes -5. The opposite of -1 would be 1, plus 1 is 2. Okay, plug in a 0 and you get 1. Okay, so now I can go find out which picture we want. So we want a closed circle at -1, -3. Let's hope we have some decent scales. Closed circle at -1, -3. Let me zero in on this. Take a look at this one. Looks like every one of these is going by 2's. So -1, -3. All right, that looks like closed circle. And then it has to go through the point. What was the other one? -2, -5. -2. And then, yeah, that looks about right. Yep, okay, all right. It's going in the right direction. And then, the open circle would be at -1, +2. Okay, that looks good. And it goes through the point 0, 1, which is right next to it. Yeah, that's good. All right, choice C it is. That is your answer to that question. Whoa, what happened? There's a question 6. Gee whiz. All right, so domain. In this particular case, for the letter, if you smashed all the points onto the x-axis, just kind of pushed all of them forever and ever and ever, you would go from -infinity to infinity. All right? Now, what if we now use the idea of pushing every point onto the y-axis? Okay, now I want to zoom in on this just a little bit and erase, oops, sorry. Got to erase it the right way, otherwise you won't be able to tell what I'm talking about. Okay, now when we start talking about pushing points to the y-axis, all right, we want to be careful. Like we got all these points down here, right, and all these points over here. But the one thing you're not going to get is +2, because there's an open circle right there. So you could put an open circle right here and then say it's everything down below that. That makes sense. So my range here is going to start from 2 and go down to negative infinity. But we want to say it with the smallest value first. So we should really say negative infinity to 2. Now this time I'm going to put the parenthesis on 2. We always put a parenthesis on infinity and negative infinity, but I have to put a parenthesis on 2 because it's open. It's not closed. The last one I had to do was closed. Why was that? Because when we looked at the picture, which I can't seem to... If you look at the picture, the bottom value was a solid dot. That's why we had to include it. Okay. Moving on to 6. This is 6. All right, here we go. Back to a different color. So we have to choose -1 and something smaller. So I chose -2 and plug it in. So we take these points and plug them into this one. -1 plus 4 is 3. -2 plus 4 is 2. And then if I take these and plug them in here, 2 plus 2 is 4. And 0 plus 2 is 2. Okay? Now we can come over and start looking at our graphs to see which one matches up. And I think I'm going to move my face for a second so I can get a different color. And let's go with green. So -1, 3 is supposed to be an open circle. This one right here is supposed to be an open circle. So -1. Each one of these are all going by ones. So there's a -1, 3, which is an open circle right there. And then the next one is -2, 2. Okay, that's matching. So far, I like B. B's looking good. That one has a wrong starting point. Now, this one is a possibility only if the closed circle on the other line matches up and lands on top of the open circle. So if you had an open circle, right, and then a closed circle that was on top of it, then you wouldn't be able to see it. Problem is, I see that the closed circle is at -1, 4, so it's not going to be this one. It's not going to be that one, obviously. This is not at -1, 3, so it's not going to be this one. It has to be choice B, and I don't even really have to go through the other part, however I can. More importantly, I probably need to look at the domain and range, right? Domain's going to be pretty obvious on these folks. It's going to be from -infinity to infinity. The range is the real issue. And if you took the values and you smashed them all together, right, pushing them all to the y-axis forever and ever and ever and ever and ever, it looks like I have a solid dot at the top and everything would be from there on down. So that would be from 4 down to -infinity, or as we like to say, smallest value first. So -infinity to 4. Once again, apologize for the extremely long video, but this stuff's important and I just want to practice more of it with you so that you're not frustrated when you're doing it yourself.